So I hope you guys did the mini Desmos investigation before starting this video. If you haven't, please stop, go to Desmos, graph each quadratic relation, and make some observations about the zeros and the vertex, and try to make a connection between the vertex and the x-intercept and the equation. Otherwise, we're going to look at how to find the vertex by averaging the zeros. So if you looked at your different equations, and you found your x-intercepts, you should have seen some connections between the x and y coordinates of the vertex. The easiest one to notice is that the x-coordinate of the vertex is the average of your zeros. So for the first one, if I average the 3 and the 5, 3 plus 5 is 8 divided by 2, here's the 4. Negative 1 plus 3 is 2 divided by 2 is 1. There it is. Okay, so that's the main connection between the x-coordinate and the zeros. Now the y just takes a little bit of outside the box thinking on how to get a y coordinate if you're already given the x. So we're going to look at that on the next page. So I hope you did make some observations, but like I said, the x coordinate, just average the zeros. So whatever those zeros are, the general ones are s and t, add them up, divide it by 2, and you'll get the x coordinate of the vertex. For communication, this is what you should be including, x with a subscript of v for vertex. To find the y coordinate, all you're going to do is plug that x value that you found in step 1 into your equation and just simplify it. And that's going to spit out the y coordinate. Then you can put it together and there's your vertex. Okay, so let's put it in that information into a nice summary box. Okay, so average the zeros to get the x-coordinate. And if you want to make a little note of what that means, add them and divide by 2. Okay, once we have that, that's step 1. Plug x value in for x and simplify to get the y coordinate. So if that second step is a little confusing on how to get the k value, not to worry, we're going to do an example together right now. Okay, so given the equation y equals 1/2 x minus 2 times x plus 4, state the zeros. What's really nice here is that the question was nice enough to give you the equation in factored form already, which means I can take my zeros by just taking the opposite signs. So my zeros are 2 and negative 4. Okay, so it's like I'm solving each equation. Now to determine the x-coordinate of the vertex, okay, so xv, I'm going to add the zeros and divide by 2. So that gives me 2 plus negative 4 is negative 2, and when I divide that by 2, I get negative 1. So there's the x-coordinate. Now, I'm just going to do a little substitution, a little calculator work to get my final answer. So y equals 1/2, and instead of x, I'm going to put negative 1 because that's what I just solved for, minus 2, and then negative 1 plus 4. Now I just simplify. Okay, you can use your calculator and do it all in one step, or you can simplify each bracket and then multiply your 3 numbers. So negative 1 minus 2 is negative 3, negative 1 plus 4 is 3, and now if I do 1/2 times negative 3 times 3, I end up with negative 9 over 2, or negative 4.5 for graphing reasons. Okay, but I'm going to keep it as a fraction. Okay, so the vertex is negative 1, comma, negative 9.2. Okay, and now we have to graph our parabola. Now usually we would use the vertex and the step pattern, but the fact that I'm given the vertex, well, I found the vertex, and I know what the 2 zeros are, 3 points is plenty for graphing. So all I'm going to do is go to my graph and plot those zeros that I found, the 2 and the negative 4, and then I'm going to plot my vertex, which was at negative 1 and negative 4.5. That's enough information. I don't have to use my step pattern here because I have my zeros. And there it is. It's graphed. Okay, so again, I averaged my zeros. I took that x value, plugged it into the equation, and simplified for the y. Okay, so using what I just did as a model, I want you to try number 2 on your own. So state the zeros, find the x-coordinate of the vertex, find the y-coordinate, and then create a little sketch for yourself. So pause the video right here. Okay, so your zeros should have been -5 and -1 because we took those opposite signs. When I added them and divided by 2, I got -3, so that's the x-coordinate of my vertex. And then I took that -3 and replaced the x in my equation and just plugged it into my calculator and simplified to get -8. So I plotted the vertex, which was -3, -8. I plotted the zeros and connected the dots and put arrows. Here's a little logic check for you. If you know what your zeros are and you start trying to find the vertex and it doesn't make sense, like if the dot was completely off the page or it was to the right of the graph and it just didn't make sense for the connection of the dots, then you know you did something wrong. Okay, so now we are going to try number 3 together. Determine the zeros and the vertex of y equals -3x squared plus 12x by averaging the zeros. You can find the zeros by factoring or using the formula. So if you want to use quadratic formula, go for it. You can totally find the zeros that way. But this question is actually a really nice common factoring question. Now here's another communication tip for you. When you're finding the zeros and you have to factor first and actually solve your equation, you need to show me that you know that zeros occur when y equals 0. So I replace y with 0, and now I'm going to start factoring. So my common factor here is -3 because the first value is negative, and they all have an x in common. When I do my factoring, I keep the -3x on the outside, and I'm left with x minus 4. Now, I can find my two zeros. From here, if we want to solve, it's -3x equals 0, and when I divide out that -3, I'm left with x equals 0 as one x-intercept, and then x minus 4 equals 0, so that x equals 4 is the second x-intercept. Now, I can go ahead and start solving for my vertex. First thing we want to do, average the zeros. And again, look at my notation. X subscript v is equal to, add the zeros, divided by 2, and I get an x-coordinate of 2. For the y value, if you want to put a little subscript of v, you can do that as well. And now when you replace x with 2, you can use the standard equation that you were given, or you can use the equation that you factored. It's really up to you. I'm going to use the standard one, just so that we have something new. Okay, and here I'm actually just going to go to my calculator and plug that in. If you wanted to do it by hand, you have to follow BEDMAS. So I do my exponent first. 2 squared is 4, and then 12 times 2 is 24. -3 times 4 is -12, and then when I add on the 24 at the end, I get 12 as the y-coordinate. So that my vertex is 2, 12. And there's all the key information. Okay, so sometimes you will have to factor on your own first before you can get to the averaging the zeros to find your vertex. Okay, so I want you to try number 4 and 5 on your own. Okay, number 4 and 5, they're not common factoring only, they are trinomials. So make sure you look for a common factor first if you can. If not, jump to the decomposition. So go ahead and pause the video and then we'll take it up. Okay, so for number 4, I did a common factor to make life easier, and then I had a nice simple trinomial. My magic numbers to get a product of -16 and a sum of -6 were -8 and 2. So I put those into my brackets and then solved my equation to get 8 and -2. If you're not a fan of factoring and you want to do quadratic formula, by all means, you should have still gotten the same zeros as I did. And then when I averaged the zeros, I got 3 for the x-coordinate of the vertex, I chose to plug it into my factored form just because it seemed a little easier. You could have done the standard form, especially if you did quadratic formula, but either way, you should have gotten -50 for the y coordinate so that your vertex was 3, -50. Okay, if you got that right and you feel comfortable with averaging the zeros to find your vertex, try number 5 on your own. So pause the video, try it, and then check your work. Otherwise, stay with the video and I'm going to go through number 5 in a little bit more detail. Okay, so here, there is no common factor for me, but I do know I'm going to start with 0 equals, just for proper communication. And now, to find my magic numbers, I need a product of 28 and a sum of -16. And my magic numbers end up being -2 and -14. So I'm going to decompose that -16x into -2x minus 14x plus 7. Again, you can do quadratic formula here, not a big deal. I'm just going to factor it though. Okay, so I have a common factor of 2x from my first pair, so that I'm left with 2x minus 1, and then a common factor of -7 in my second pair, so that again, I'm left with 2x minus 1. Brackets match, which is excellent, and I'm left with 2x minus 1 and 2x minus 7. Now in this case, when we solve, we're not going to have nice, pretty zeros, like whole numbers. We do have to do a little bit of solving. 2x minus 1 equals 0. I bring that -1 over, so I have 2x equals 1, and then divide out the 2 to get x equals 1/2, which we can also write as 0.5 to make life a little easier. I do the same for the next one. 2x minus 7 equals 0. I bring that 7 over, it becomes positive, and then I divide out the 2 so that x equals 7/2. And to make life easier, just because it is a nice terminating decimal, I'm going to turn it into 3.5. I have my zeros, that's excellent. Now I can move on to my vertex. Okay, so what's the first step? Average the zeros. So add them. So 0.5 plus 3.5, which is 4. And then we're going to divide that 4 by 2 to get 2 as the x coordinate. And now we replace x with this 2 value in either the standard or the factored form. I think I'm going to go to the standard one. So 4 times, instead of x squared, I put 2 squared. Minus 16x, so 16 times 2, and then plus 7. Simplify this a little bit. 2 squared is 4. Please, please, please do exponents first. Don't do 4 times 2 and then raise it to the power of 2. It will be wrong. -16 times 2 is -32, and then the plus 7. 4 times 4 is 16. And then minus 32 plus 7. Go to my calculator to simplify this. 16 minus 32 plus 7, and I get -9. So that my vertex is 2, -9. And that's it. So factor, or to use the quadratic formula to find your zeros. Okay, make sure you're showing me that you're replacing the y value with a 0, because all of the x-intercepts have a y coordinate of 0. Once you find your zeros, average them out. So add and divide by 2. Once you have your x coordinate, plug it in for x, whether it's in standard or factored form, and simplify to get the y coordinate. And that's it. That's the first method for you to find the vertex of an equation if you're starting with standard form or factored form.